Let's talk about the definite for loop, which now starts to become a more interesting structure for us. When you have simple arithmetic values like integers, floats, you can do expressions, mathematical, but sometimes we want to store information, and that means we need to have a compound structure known as lists. And I've used this a number of times. I've got a set of values. These are 3 values that I'm keeping track of. I might have them for a number of purposes, but one of them is normally I want to print all of them one at a time. For this to work, I need to be able to iterate over every element in that list. That's what this one is over here, DT10. Once you have that in mind, you can do so much. Now to do that, the structure is called a definite for loop. And a definite for loop says, let me do something for every element in a list. All right, well in this case, I'm just going to print the element out. This for loop defines a new variable called element that didn't exist before. It now goes and it has the 3 different values that are set once, twice, 3 times, each separate time through the loop. The first time through, element is 1. The second time through, element is 2. And the last time, element is 10. In fact, right now, the for loop is done. Element is still 10 because that was the last one that it saw. This for loop allows you to do any number of operations, and you just put them together here, and you are very careful to know that the value of element will change each time through the loop. It will execute a definite number of times. Exactly how many times is based on how many elements were in the list in the first place. When I put all this together now, I have the ability to construct a list of multiple elements and iterate over each one at a time. But there are times when you want to iterate something a fixed number of times, 3 times or 10 times. And Python has a very specific structure that lets you do that, and it's called the range function. So let's say I wanted to do something 5 times. This for loop will have the exact same structure you saw before. It's a definite for loop, which means it's going to do something a certain number of times. And this is a very simple convenience to look at this and recognize that it will do something 5 times. And this print statement is then executed 5 times. There's really no magic going on here. Range of 5, as you've seen from the lectures, is a function that returns a list of consecutive integers from 0 up until, but not including, the integer that you passed in, thus ensuring that there are indeed n elements in that list, or 5 in this case. So the range function is very useful when put together with a for loop. And so if you put all these things together, you now have the ability to deal with lists, process them, and iterate over them. In the last 2 lectures before the exam, I showed you how to do some very specific manipulations of a list. If you have a variable like x being 6, I just set x to be 5, well now I know that the value has changed to be 5. But when I'm collecting together a number of values in a list, how do I change just one of them? Or in fact, how do I add an element to the list? So the first thing to deal with is how do I insert an element into a list? The simplest one is called append. And this is a specific notation called the dot notation that says, or Python asks, to add to the vals list a number, in this case 99. So my vals now has 3 elements. Now has 4 elements, where before it had only 3. What if I want to do more than just add elements to the list? What if I wanted to retrieve an individual element by its location? And the notation for this is a bracket notation. And the way that you want to interpret this is that vals is a list, and you are asking for the 0th entry. And the 0th entry is the one who's at index position 0. Every list is positioned with an index value that's going to be 0 and higher. 0, 1, 2, 3, and each of those values has a certain value. Vals of 0 is 1, naturally. Vals of 1 is the element you see here, 2. Vals of 2 is 10. And it takes a little bit getting used to because it's a mathematical way of looking at things. But to retrieve the 3rd element from a list, when you're looking at it 1, 2, 3, 4, you need to use the index position 2, because after all, counting mathematically, the first element is the 0th one, the second element is the first one, the third element is the second one. It takes some getting used to, but it's worth it, because every other programming language, including MATLAB and C and Java, always refers to elements in a collection using 0 as the first one. We have to get that firm in our mind. It takes some time to get used to it, and so I will repeat it pretty much from now until the end of the course. And by the end of the course, I'll have drilled it into you enough that you'll just know it. So this is how you construct a list from scratch. You can start with an empty list, which is open bracket, close bracket. As you see, it has no elements. This is very similar to having an integer defining it as 0. And when I have an empty list and I want to add an element to it, I can add append. Now I have it. I can keep on doing this. Now I've got 2 8s. I'll do one more. And once again, you can see how you can retrieve the third element by looking at index position 2. So we've been able to insert an element into a list. You've been able to access individual elements, but I haven't shown you how to modify individual elements, although I've done this in the lecture. If you want to replace the first element in the list with another value, you say vals of 0, because after all, that's the first index position. And you say equals a number. This is just like how you assign a variable. In this case, the vals of 0, that's how you would read it left to right, vals of 0 is set to 13, and that tells me that the 0th entry in vals, or the first one that you see there, will now have the new value of 13. So you are now able to insert an element into a list, access and modify individual elements. We've defined a number of functions in this class so far. It's not that hard to define a function. You use the def keyword, all lowercase. You give the function a name, a unique name that you want to refer to that function by in later times. And then you have a sequence of statements. Each one is indented, so Python knows that those are the statements that are associated with my function. You may have another function, and you might say, well, how do I know when the first function ended? Well, you know it ended because you had this non-indented blank line that terminates this. So that my def another function is in fact a new function that you're defining. With all of these functions defined here, I can call my function, and I see it prints first, second, third. I can call another function, and you see it just prints 4. Functions are exceptionally useful, and we are now moving into the part of our course where we need to define these functions more and more as part of our strategy for breaking down problems into smaller subproblems. Functions are very powerful. They also allow you to pass in what are called parameters that I can use to change the behavior of the function. You've seen this on some of the assignments as well as the self-assessments. Let me pass in the temperature, for example, here, and I will write a function that prints something interesting, I guess I would say. Let's call this function how does it feel? Okay, that's my function. All right, let's do a simple one. If temperature is less than 32 degrees, I'm going to say it feels freezing outside. All right. What about some other ones? If temperature is greater than 212, print, are you kidding? It's boiling outside. And then room temperature, you can define it any way you want. Most people define room temperature between 65 and 75 degrees. Is that room temperature? So now this function does one of 3 things because each of these is relatively, well, they're all disjointed. How does it feel outside when I pass in 10 degrees? It feels freezing. But what if I pass in 300 degrees? It's boiling. So you see how with a function with a parameter, you can change what the function does based upon the input that it has. It's a very useful feature, one that you're going to come to depend on in the latter half of this course, latter 2/3 of the course. We're now running into 20 minutes, and I like to keep my videos short at 20 minutes long just so that we don't clog up the YouTube servers and also makes it a congestible bit of knowledge for you. So this is the first part of the exam, and I will now complete the remaining skills in the next video.